So what we did is we basically first looked into the capabilities we have for product managers, right? Like for Tom. Then we looked into R&D capabilities, the capabilities we have for people like John, who represents the R&D head in this scenario. Next, we would like to now talk a little bit more about digitization. And here we have Eva as our Chief Digital Officer in this scenario. And we would like to address a few needs for digitization initiatives in a company. In general, when we look into our end user research for CDOs, what they all have in common, they want to digitize business processes and they want to avoid media breaks across line of businesses. Because what we see when we look into the end-to-end supply chain, we see that the different functions, engineering, manufacturing, asset management, often work in departmental silos. And with the new CDO functions being more and more popular in organizations, we see the tendency that these CDOs, they don't want to integrate these business processes and the line of business functions more closely in the future. And what they're also looking after is they're looking after new business models, right? So they're asking questions on how can we create new commercial models, new subscription-based services, which we can basically sell on top of the traditional sales we have for the products we're developing, right? And in general, they're on a mission really to display thought leadership by also using new technologies. On the other hand side, they also face, like the product management roles or the R&D roles, they also face some challenges. So I talked about the legacy systems in the R&D context already, right? But these legacy systems and the custom developed solutions often slow down digitization initiatives. At the same time, the functional silos across the value chain, they basically also just strengthen this problem, right? That we basically see. And also what we also observe is that every company, as you know, right, the famous quote, every company becomes also a software company. And especially when you want to digitize your product offering, right, the lack of experts and the talent shortage you have in the industry also slow down digitization initiatives out there. So, and we want to address these shortcomings with our EPD capabilities. So we want to improve the collaboration between development, manufacturing, and asset management by creating this integrated digital thread. And we want to give people like Eva and her team members tools to increase customer satisfaction and also improve the aftermarket sales, right? And we want to enable them to basically take product data from the engineering world into all the downstream processes, right? And at the same time, we also want to enable Eva to work on new business models. In order to achieve all of these goals, we have three major capabilities in our EPD portfolio. Two quarters ago, we launched a new handover capability. This handover capability enables us to take engineering product structures and transform them into manufacturing bill of materials. And here we tightly integrate EPD with S4 to basically take that EBOM into an MBOM. But this handover capability will evolve also over time, and we want to use this handover to keep the different product structures and bill of material types like EBOMs, MBOMs, transportation BOMs, installation BOMs, whatever order BOMs, right, always synchronized. At the same time, right, we want to make this handover process also as visual as possible. And we will now, in the next few minutes, talk about visualization a little bit more in detail, because this is how we will continue to evolve the SAP Enterprise Product Development to become a highly visual 3D-based PLM solution, where we enable our product development teams to deliver not only EBOMs into downstream processes, but also treat 3D drawings, right? Also in the same way, and establish the digital thread so that you can bring design data into, for example, service-oriented processes. And this is where Nick will now in the next minutes provide a bit more details on this and explain our strategy for visualization in this context of a digital thread. And last but not least, we have also an IoT capability in SAP Enterprise Product Development, which enables us to get IoT data, sensor data into EPD and combine the IoT data, for example, with engineering simulation models to calculate, for example, the asset health of products you have in operations, and based on these insights, make more informed decisions about when and to how to operate an asset. And we can, if you're interested, use one of the next webinars to also provide more color on this field. With that, Nick, I want to hand over to you, provide us a deep dive into visualization and what we have planned for the next years. With that, over to you, Nick.
Hey, thank you everyone for joining our event today. My name is Nick Wang, and I'm the product manager for EPD visualization. Today, I will present you the visual design to service, and as you notice, this is a strategy. So it's not yet implemented. It's rather a vision that we will be working towards in the future. And you've heard that Ismail and Carsten have stressed several times the importance of establishing the digital thread. So essentially, this strategy is about implementing the visual design data all the way through to the service within various SAP solutions or applications. I've got several topics that I want to cover today. First, I will provide you with an overview of what the design to service strategy is. Then I will walk you through some of the visualization capabilities which can be potentially leveraged through the processes, including a couple of demos. And I will give you a sneak peek of what the art of possible if we do decide to move forward with the integration, right? So how does the end-to-end process could possibly look like in the downstream solutions? So what is visual design to service strategy? It's about enabling the visual digital thread from products directly from CAD to SAP technical objects. So within Service Cloud, it's called registered products. And in intelligent asset management, we call it equipment. But really, this is design data, both 2D and 3D, being uploaded into EPD visualization and be reused by the downstream processes. And why having this digital thread of visual data is critical, because this allows the authorized service provider for the OEM manufacturers to leverage the visual data through various SAP service management solutions and help those manufacturers manage the end-to-end service lifecycle, ultimately increase the service efficiency and customer satisfaction. Okay, so basically after the CAD files are imported into EPD visualization, we tag the visual object with the business data and use authoring tool to enrich the visualization, for example, change the appearance of the model by applying different material or creating the visual working instructions and so on. And once the visualization is published in EPD, we will then push the visual data into S/4HANA, which then through one domain model and master data integration, it can be distributed and synchronized to the downstream processes or solutions like Service Cloud, Field Service Management, Service and Asset Manager, all the way down to the execution in the field, as you see on this slide. So by doing that, we are not doing point-to-point integration with each individual capability or solution. So essentially, the visual digital thread starts in EPD and seamlessly flows from design to service. And in summary, what we are proposing is a full cloud end-to-end solution. S/4HANA would be the digital core, and obviously, our service solutions in the cloud, as well as the mobile delivery for the execution of service. The input of this process comes from both 2D and 3D of the mechanical CAD software. So likes of Siemens NX, Solid Edge, CATIA, SolidWorks, Creo, and so on. And essentially the first question we're being asked was, well, how do we hand over this information? Well, within EPD visualization, we have the ability to basically restructure from engineering BOM to any structure. We do that through a tool called association. And you will see this a little bit further down in the end-to-end process. All right, so we start with the native CAD files. It could be a visualization, a derivative of that JT, for example, or 3D XML from CATIA. Doesn't really matter because EPD visualization support most of the native and the interchange file format. So we can bring the CAD files into EPD visualization and visualize it. Within EPD visualization, we have a number of capabilities. The last three capabilities, which will be potentially leveraged by the downstream service solutions, they are visual spares and service, visual work instructions, and the product model viewer. I will spend some time to walk you through each of these three capabilities over the next few slides. Okay, so one of the capabilities is the visual work instructions. Visual work instructions shows how to assemble a product on the shop floor or how to maintain some equipment installed in the field. It enables the manufacturer or service provider to transform the 3D product data into the interactive service instruction, which ultimately increase the service or production efficiency. Imagine if the service technician are sent to the field to fix something. They can leverage this visual work instruction to see exactly what needs to be done, and which will increase the productivity, accuracy, and ultimately customer will be happy. And visual work instruction can also be used for manufacturing, asset management, or even logistic to show how the product is disassembled and reassembled on site. Okay, I will talk about the process in the next slide. Okay, so basically this is the end-to-end process of creating a visual work instruction. User starts with importing a 3D CAD file, then using association to create a new visualization structure and connecting the visual object with the backend business data. Then use the visual authoring to apply different material or create animation or annotation into the visual work instructions. Then user can also create a viewer template within EPD visualization for a specific persona or use case. The last step is to publish the visualization. And I just want to also highlight that we actually have a planned innovation in our roadmap that we will support change management for authored visual content, meaning that the user will have the ability to update the visual work instruction if there's any change to the original CAD design. And this is just showing you the visual work instructions that we've created for EvoVolve. As you see here, we have tagged each one of those nodes with appropriate global unique identifier. It could be a material ID, or could be a functional location or equipment ID, doesn't matter. Basically, we can assign any type of usage ID to the visualization, which makes the visualization a business context where user can retrieve information for any node or object from any system. In this case, we have tagged this visualization with product code for Commerce Cloud, but also as designed, which has the material ID here. As I mentioned earlier, our view template is highly configurable, so user can now create a custom 3D user interface by persona. So basically, this view and look can be changed accordingly by the customers. Now, let me quickly show you how this visual work instruction we created in our demo system. Okay, as the visualization is loaded in the viewport, there's a toolbar on the top that allows user to perform some basic actions. If user wants to search for a particular node of this model, for instance, the shaft seal in my slide, is worn-out. How does it look like? Where it locates? You can use this filter bar to search either by name or metadata or usage ID. Okay. In this case, I will use the usage ID because I know that the visualization has been tagged with as designed, as I showed you. And I will use partial product code or material ID, I should say, for that shaft seal in this case. So you can sort of see where that shaft seal is located, but to make it more visible, you can use right-click and click isolate. Basically, this will isolate all the other components, just showing you the selected parts that you want. And to play the animation, simply click Gallery tab. You can either play the selected view of the animation, or you can play the entire 3D visual service instruction. In this case, I will do that. And in addition, you can merge the visualization into this model. The arrow you just saw is an example. So for instance, whoever created this visual work instruction can also add some health and safety symbols to enrich the animation content, all right? So this visual work instruction basically shows how the EVO valve is disassembled. And once the technician replaced the shaft seal and how it's reassembled back. The user can also add some annotation onto the work instruction to help the service technician to understand more information how to assemble this part. And now let me switch back to my slide. Here you actually notice that I have made a selection on this model. So I selected the shaft seal because in this case, the EVO valve has been leaking because the seal is worn out, as I said. Now, what if we wanted to replace the seal with a new one? How do we quickly identify and order this component from the spare parts catalog? And now this brings us to the next use case here, visual spares and service. So visual spares and service is an integration of EPD with SAP Commerce Cloud, which has been released earlier this year. It enables the OEM manufacturers to leverage the 2D or 3D visual data to build an interactive spare parts catalog. As a result, it minimized the time wasted, for example, trying to locate the correct spare parts, resulting in lost revenue due to the critical products. Visual spare and service is an end-to-end process from design all the way to commerce. It enables the OEM manufacturer using visualization and integrate it into SAP Commerce Cloud to go after their B2B customers or authorized service provider. So how does the actual process look like? Well, the first few steps are very similar to the process of creating visual working instructions. The difference here is once the user finishes the authoring, then they make the visualization accessible to the Commerce Cloud storefront by publishing the visualization to a folder that is enabled for Commerce Cloud storefront access. And moving to the Commerce Cloud side, customer will use Spartacus to develop their web store for the spare parts purchasing and configure the Spartacus storefront for EPD visualization. And this just showing you an example of streaming visualization into the viewport so user can make selection for the spare part they need. Again, I will show you how this visual spare part selection works in our SAP Commerce Cloud. So here I'm in SAP Commerce Cloud. You see this 3D EVO valve. It has been tagged with usage ID. In this case, is the Commerce Cloud usage ID that I've shown in the previous slide. If I scroll down in spare parts tab, I'm now streaming the visualization into the viewport directly from EPD. Okay, so I can do the rotation. I can do some other activity. I can play the exploded view of this eval valve. Again, all the authoring preparation work are done in EPD visualization. So if the service technician wants to check this pressure spring, as soon as he selects this part, it will also highlight in the SBOM on the right. The user can also use the filter bar to search for the spare part they need. I will again use the shaft seal as an example. So you see that as soon as I type shaft seal, it minimizes the options for the spare part selection. And here I can see where the shaft seal is located. How does it look like? I can also use the partial product code to search for this spare part. Okay. So once I select this spare part, I just simply add to the cart, like all the online shopping experience, and that finish the spare part purchasing. And let me just jump back to the slides again. Last but not least, Product Model Viewer, which is a mobile application that will have its first version released in November. It displays the 3D models from EPD visualization. It allows engineers, shop floor workers or service technician to view the step-by-step 3D visual service instruction created in EPD. In addition, user can also select the parts and view the relevant product or equipment information. Next year, the team will be working on the integration with the SAP Service and Asset Manager, which is also an application, mobile application, which enables the user to navigate from Service and Asset Manager to Product Model Viewer, where they can create a maintenance notification as example, or check the relevant business data. Process-wise, it's very similar to the previous two use cases that I've talked about. Again, once the visualization is prepared in EPD, user can stream it directly into the Product Model Viewer application. This just shows you that the user can either select object rendering mode or AI mode, as you see on the slide. So not only they can interact with the large 3D models, but also user can view the animated step-by-step visual service instruction, as I said earlier. And this shows the user can select a part or assembly to view the CAD or enterprise information, which is synchronized with the master data in the backend. So this application really allows the user to access the business data anywhere and anytime. Now you may be wondering what this process might look like from an end user perspective. Let me quickly show you this over the next few slides. Again, these are just mock-up. It doesn't represent the actual user experience that may get implemented by development if the integration moves forward. And just let everyone know that we will be running a customer engagement initiative from next month regarding this topic, workflow automation for EPD visualization. So for those of you who are familiar with Visual Enterprise Generator, this project is exactly what we're trying to do in the cloud, meaning that user will have the option to create and manage the workflows in EPD visualization. So if anyone is interested about this topic and have not registered yet, please reach out to me directly and I will add you onto the registration list. Okay, so now we come to Service Cloud, specifically in the agent desktop. This is a solution that the Service Call Center would typically use for the OEM manufacturer. And one of the capabilities within the agent desktop is the ability to create a service order for a particular customer. So when the agent creates the service order to schedule a service, they click this create button and scroll down to the service order. It says fill rate, because essentially this is a mashup of S/4HANA service order creation. So basically, it will load the S/4HANA transaction screen for service order creation inside of Service Cloud. So the Service Cloud screen that you will see in the coming slide will be embedded on the lower part of the agent desktop screen here. Okay. And now we come into a service order screen. So once the agent creates the service order, and they need to choose the right spare parts for the service work required. Today, without a visualization, the agent will have to look up a part number or the description for the spare part in a textual manner. And the idea is to enable the visual digital thread into service management so that agent can leverage the existing design data for the spare part selection that gets added to the service order. So this is just a digital mock-up of a potential screen that allowed the end user to filter by name or partial product code, or visually select and confirms the proper spare parts to add to the service order, just like you see in the Commerce Cloud. And by clicking the Add button, they would use those selected spare parts, and that will add into the service order, which are also reflected here. And by now, the service order is ready to be released. And once it gets released, it will take the service order to a scheduling application, as you see on the screen. In this case, this is the SAP Field Service Management. And the service planner will now going to select this service order and drag and drop into this intelligent scheduling window, which will look for a technician that has the availability and meets the requirements specified in the service order, and place that service order into schedule. And when the service gets scheduled, the service technician will then receive a prompt message in their service and asset manager application saying there is a new activity or a new service job. Again, the visualization that will attach to the service order are also available in this application here. The service technician can see all the relevant details of the scheduled work in this application, including the customer information, spare parts required, warranty information, or requested starting and completion date, so on and so forth. As I mentioned earlier, we will have the integration between a product model viewer and the service and asset manager in future. So when the service technician is carrying out their work on site, they can leverage the visual service instruction and or augmented reality to help them complete the work more efficiently. In the future, we are also going to have dynamic forms in the service and asset manager. Essentially, we will have the ability out of box to create 2D service instruction, and more importantly, the ability to validate each step in the process. So, the service technician click on this yes or no after a step is completed and signs off when the job is done. As an OEM manufacturer, your authorized service provider is exactly following the standard service procedure and signing off during the execution phase. And here's what the particular dynamic form looks like at runtime on a mobile device. In addition to supporting the 2D service instruction, we also think there is a huge value to augment the 3D visual service instruction, meaning displaying the information through the camera on top of the actual physical device and pointing the service technician exactly what they need to do in an augmented way. Again, we are still exploring different options at this stage, and we will share more update on our roadmap in the future. With that, that concludes my presentation today. I would like to thank everyone for your time, and I now hand over back to Ismail.
Thank you so much, Nick. for the presentation on our design-to-service strategy. Very exciting, right? And again, also under the umbrella of the digital thread again, right? We want to enable that product data can move from left to right in the value chain, right? Transforming the visual context, right, in terms of 3D models from the development stage into the downstream asset operations, right? This is SAP's kind of secret sauce, right, when it comes to how we differentiate with our competitors in that field, right? Because again, we want to connect PLM with ERP and all these supply chain solutions and have a highly integrated business process, and that also includes 3D models. So let me grab the screen share again. Nick, there are a few questions for you.
One question I think which we could kind of give a little bit of a shout out here in the common call. It's to Nick. Visual design to service is relevant only for discrete industry. Can you comment on that, please?
Yeah, great question. Look, in the first phase, again, we're still talking about strategy at this point of time. But in the first phase, we want to focus on the OEM manufacturers, meaning discrete industry. So as we, test the feasibility and do more POCs internally, surely we will extend this strategy to other industries. But for the first phase, we will focus on the discrete industries.
Thank you.